Hi, welcome. Thank you for being here. I'm Andrea Chomiak, and this is actually my first KubeCon talk. And I know that KubeCon is full of technical talks, and today I want to take all that technicity from a different angle, which is usability and design, because it doesn't matter how technical or advanced our systems are if people can actually use them, right? So in this session, I want to share with you how good design can help engineers actually turn noisy data into clear insights. But first, a quick intro. A designer in this world is not always having fun. So I work at Dash0, and Dash0 is an OpenTelemetry native observability tool where my job is to take really complicated observability data and turn it into something that people can actually use and understand. And that is exactly what I want to share with you today. Some of the techniques that I use to get there. So let's get started. Before I share with you these techniques and design principles, I want you to empathize with the pain. So for that, imagine this. It's 2 a.m. and you're fast asleep, but you're on call and your phone goes off. So you open the notification and it says, system degraded, that's it. You are not sure how bad it is, but you got paid, so you wake up and you get on with it. And there is a link to a dashboard. So you click on it and you start digging around, a lot of tools, logs, traces, events, and probably too many dashboards. You end up unsure if you need to wake up someone else or just hope for the best. And probably you've been there at least once in your career if you're an engineer. And the interesting bit about these situations is that we tend to blame the tech. So we start asking ourselves, like, OK, maybe it's related to the pipelines, or it must be related to infrastructure or the configuration. But what if the real blocker is how the data is presented? Because if during an incident, a dashboard makes you more confused, that's probably not a data issue, it's an usability failure. And now, after the pain, the good news is that we're shifting, thanks to tools like OpenTelemetry, from isolated signals to correlated insights. And that means probably the end of the eternal tab hopping that we were just mentioning, and also the possibility to have the full picture of what's going on with your systems. And also, when these correlated insights meet good design, we finally get clarity. And clarity makes our brains happier, especially when things are on fire. But how to get there? I already made you empathize with the pain and the potential, and now I'm going to talk about the how. And for that, I picked some of the design principles that I think are the most important and also practical, so you can start implementing them and understand why they are so important to get there. And I'm going to start with clear information hierarchy. And this sounds obvious, but it's not always what we see around us. And it's because every good observability tool and actually every good design must have clear information hierarchy. Because if your users or if people don't know where to look at, they will probably end up not looking at anything at all. And now I prepare a quick gut reaction. And when you take a look at the screen, which circle do you pay attention to first? Probably, most of you follow this exact same path. And that is not coincidence, it's actually human biology, because our brains naturally follow size, color, and alignment to process information. And we, designers, use that to drag your attention to the most important stuff first. When you take a look at this hexagon filled with a lot of colorful hexagons inside, and you try to figure out which one is the most important, probably you won't have an answer for that. And that is because all of them are shouting at you at the same volume. So you end up hearing nothing but noise. And by the way, this is a bad example. On the other hand, when you take a look at this screen, you can feel how your eyes are attracted by the red dots on the histogram. And that is hierarchy at work. And this is especially working because everything else on the screen, all the other elements, remains quiet. So you can focus on what is important to you, and then, of course, you can drill down even deeper and add more complexity only if you want to. And that's my next design principle, which is progressive disclosure. And progressive disclosure means that we provide people with a clear path that they can follow, revealing complexity only when they ask for it. In observability, this should feel like telling a story. And like every story, it starts with an event. In our case, that will be something broke, unfortunately. And then the question that you may ask is, all right, like where this is happening, which cluster, which environment, then how bad it is one request, 1,000 requests, is affecting a lot of users or none, and then what's causing it. And here's where the complexity can get even wider, and because you're trying to find the root cause of the problem that you're facing. But in the end, what do you want to do is to get a closure to your story, right? Like an alert that clears everything, or the rollback, or whatever you need to give the story an end. I'm going to give you a quick example. And when you take a look at this service map, you are focused on the red stuff, right? That will be our first event of the story, because this thing might be broken. And thanks to these correlated signals that OpenTelemetry make possible, and good design, we can have an overview like this with everything you need to follow up with this story, and also next steps. And you might be wondering, okay, but this is a lot of density on the information. But this is actually easy to process because of the way that its group makes sense. And that is my next principle, which is visual grouping. And visual grouping is important because when things are visually aligned, even in the world around us, our brain tends to process this information better and actually faster. When you take a look at the screen, this confetti screen, there is an effect in our heads, and it's because our brain can stop itself, but it's on debugging session. It starts to try to find patterns and group things to understand what's going on, right? And one way to take our brains from that and give it a break, we can group things. And there are several ways of group visually, but I'm going to share 3 that I think are very cool. And one of them is proximity. And grouping by proximity is just like taking those elements that I was showing before, and just by playing with distance and alignment, you're telling your brain this belongs together and this doesn't. And it sounds simple, but this could help us process information way faster. And you've seen this, for example, in games. I like gaming, so in inventories, you always have a lot of elements, and just by playing with a bit of spacing, you can already categorize even if you remove the titles. You've seen this also in keyboards, where some keys are clustered together, so it improves usability and also muscle memory. But our brains are also wired to spot similarities. So you can group by shape, color, or size. Because we tend to do this in our world around us. We cluster things that are similar together so we can process them faster. Whether you are analyzing server logs, like in this example, or picking up your tomatoes at the supermarket, I don't know. And here is the confetti screen again, and your brain is going into debugging session again. And it's because I want to share the last trick. And it's this. Notice at the second that I draw a rectangle around the confetti, your brain automatically thinks like, okay, this must be a group. This is related. And you've seen this in maps, for example, in patterns in games, in tree maps. And in this example, this is actually not only about grouping with visual boundaries, but also with the spacing and the similarities that I was explaining before. And as you can notice, this is a dashboard that is showcasing metrics for pods and nodes. And you have a lot of data density there, but just because you just place things in a way that are coherently grouped, you can feel it like way lighter. Yeah, but clarity is not just about how we design things visually, but also how we help people make better choices, even when it's visual design or actually designing infrastructures or systems or anything in general in life. And that's why the next principle that I picked to share with you is opinionated defaults. And what is a default? Default is actually, in design, one of the most powerful psychological forces, because once you get used to them, you rarely change them. You just do it automatically without thinking twice. Think of a light switch. When you enter to a room and you see the main light switch, you're expecting that whoever wired that thing knew your intentions of turning on the light in your room. And that's the beauty of a default, that you think it's obvious, but you're actually doing it because you get used to it. And the tricky part of this is that it's powerful, but we also need to understand when to define a default, when it's worth it. And I don't have just an answer for that, but I have some advices. And one of them is identifying painful decisions, right? Like where engineers hesitate the most, for example, setting filters or getting a certain metric, or I don't know, like whatever that you notice that the person is having trouble to move forward, that's the opportunity to offer a default and offer a solution, a strong start for them. And this is also related to the previous one, because when you know where people are having more friction, you can also investigate and find patterns in the real world to understand how these people are using what they have. And then, of course, if a default that you're proposing feels too rigid and without an escape door, probably that's not a good default, because defaults are there to help you get started, but it can't trap you. You always need to decide if you want to go to the painful path if you want to. And the next design principle is related to this opinionated defaults, because if we give people choices, of course we need to provide also guidance. And just to make sure, contextual help is not a tooltip or a dialogue that says this is broken, get on with it, right? This is abandonment in a tooltip, and I hate it, and we shouldn't do that. Contextual help should tell you, like, okay, this is broken, this might be happening for this to be broken, and also a next step. So you feel like, okay, this is giving me valuable information, right? And you've seen this like in a lot of places, like onboarding walkthroughs, cryptic metrics being explained by a tooltip, inline instructions while filling up a form. And in observability, this is actually very useful because it gives you the opportunity for faster incident response, because you can get information right in the place where you're seeing the data. It also reduces cognitive overhead because you can include a lot of explanations, so you don't need to leave the tool and go on the internet, on in Reddit, and getting lost in this rabbit hole of the internet. And also, it provides real-time guidance. When you're configuring something and you're making a mistake that is probably small, but you ignore it because you're not sure if you're doing it right or wrong, and a tool tells you, like, okay, please fix this, this will save you a lot of time in the end, because this could become a snowball that gets worse and worse. And now this contextual help is getting even more interesting, because you may know what I'm going to talk about because it's a trending topic, but now contextual help with AI, it's getting even better. Because it becomes a dynamic conversation, so it's just not a static info that is actually valuable, but now if you don't understand that information that is being displayed there, you can keep on asking questions and keep on learning from it. And this helps for a lot of things like incident investigation, because you can get a full report of what's going on, the root cause, and patterns. And also gives you actionable remediation. It's not fixing the problem, but it's helping you to understand why and how to move forward. And yes, you're continuous learning from it, and it's learning from you. So next time you ask a question, it will at least understand what do you need to do next. And I've been talking a lot, so it's time for me to wrap up. And for that, just as a reminder, I did these drawings so you remember. First, always help people to know where to look at. Also, don't throw the entire encyclopedia at once, like help them go step by step. Give the brain a break with visual grouping, and provide strong starts for people with your system, and also make sure no one feels lost with contextual help, whether it's with AI or not. And all of this is because we need to make sure that even when it's complex data and complex systems, we provide simplicity for it to be translated into something that is actionable. And this is a reminder for myself, because I wanted to talk about collaboration, because I think it's important that designers and engineers collaborate together to build better tools and better systems. And for that, I also have some advice in case you don't know where to start. And first, give feedback early. You're not going to hurt our feelings. We're used to it. And don't wait until GA or people are complaining to do it. Also empathize with users, again, empathizing, especially with people at 2 a.m. When they're trying to solve a problem. This is personal, but I wanted to add it, like, please name things for humans. And pair with us, pair with designers, sit with us, we can brainstorm, complain, and create better tools together. And I will leave you with this. Designing observability tools is not just about aesthetics. It's about making complex systems usable under pressure. Thank you so much.